me at any time. It doesn't really matter. We have, I'm just saying right now, so Beatrice, you are a scientist, right? So you're a physicist, or what is it?
Yeah, I'm doing my PhD in neuroscience, cognitive neuroscience. So my background is neuroscience and psychology.
So what is, so, okay, fine. Then we have, I'm missing some people. Did we lose somebody right now, or? I only have 1, 2, 3, 4, 5. At least I see. Oh no, there's more down here. I'm really sorry. So it was more here. Okay. So then we have Victoria is a medical student. What was your name? Stefan, right? You are also a medical student? No, what is this? I don't see your names at the moment, so I'm really sorry we're doing. So Beatrice, physicist, Moritz is an engineer, Anna is an engineer, Vutucha is an engineer. Holger is not relevant because he leaves in 15 minutes anyway, right? And we can mix later on some of the groups. Okay, let me just go through. So what this whole lecture's all about is that I would like to communicate of how to generate innovation and how to generate meaningful innovation. So I know that all of you have a different opinion about what innovation is. I have later on a question. Most of you have done that already. That's why we will not make a game out of this. But innovation is something that is fairly easily communicable. Beatrice, do you have any idea what innovation is?
Something new, like
something new.
Yeah.
Okay, let's remember that. So let me just go down here. So what is your name? I don't see your name right now. The one in my chart, it looks like it's below Victoria. Who is the one I did not call yet?
That's probably me, Christoph.
Oh, Christoph, I'm really sorry. I somehow had the feeling your first name was Stefan. So I'm really sorry. So okay, you're Christoph now. So whenever I say Stefan or Christoph, it's you, right? So you are a medical student as well, right?
Yeah, but I'm coming from the background of sports science. I was the International Master for Performance Analysis in Sports, but it was too boring for me. So I went with my master thesis in researching learning techniques with EEG. So
okay, very good. So you can connect with Holger because he's a sports scientist too, right?
Oh, okay. Yeah, now I'm doing my PhD with cognitive neuroscience and investigate the microstructures and vasculature of the motor cortex, especially the hand knob area. I want to find out what the effect of the vascular patterns are.
And what is your definition of innovation?
To create something new, not just from the scratch, sometimes also to combine two things to make something new, which has a different usement.
Okay, so something new. So Beatrice said new, you said new, Christoph said new. What does Victoria say? I'm not asking all the other ones because my people typically should know it, what I want to hear. So that's why I ask you guys specifically right now. So what do you think innovation is?
Yeah, to develop innovations, also make something new or make older ones better, maybe.
Okay, and what's the definition of better?
In front of to become early healthy, also.
Okay, so let's remember that. Let's remember new, better, different, combining things. So like that's what your definition of innovation is. So theoretically, I always use that as an example. If I have my car and I add a fifth wheel to it, this is innovative, right?
If it's the replacement wheel, yeah.
No, I'm just adding a fifth wheel to it, or maybe a seventh wheel to it. So what the heck, right? It's new, isn't it?
Depends on the purpose. If you have to carry heavy loads, then it could be useful.
Okay, but I have not said that. I just add a fifth wheel. What the heck? So that's new, right? Nobody has done that yet. Is it better? Depending. So what is one thing that is really missing on that definition of innovation you just said? Now all the other ones, everybody can throw in things.
That it's successful on the market.
It has to have, somebody has to be interested in it, right? Somebody has to be willing to not necessarily buy it, because you can also be using it. Maybe you have a new technique to drill a hole, to drill a water well in the desert. That would be very useful. But somebody has to use it and has to say that's really valuable, and better even if they've spent money on it. Yeah. So there's a formula. I come with that later on, that innovation is invention times commercialization. So if nobody is damn interested in it, then to my extent, it's not an innovation. It's just simply something new. So anyway, welcome. I will always be for you, and you will find out, maybe you have already, you will find out that when you send me a mail or you try to get a hold of me, I usually respond within, minutes, maximum hours. And so whenever you have a problem, get in touch with me, okay? So I want to talk particularly about things that will happen in healthcare. So we'll talk about innovation in healthcare. I will also question a lot of things that go on right now, and don't feel offended, because I will probably, put some, how would I say this? I will probably put a mirror in front of you and ask every once in a while, is that really worthwhile doing what you're doing at the moment? Now, if you get a PhD, it's just, I don't want to get you away from your PhD or from your MD, just continue, but I'm just trying to put in, get a new way of thinking into it. Now, in general, innovation is not something that there's no miracle. Does anybody know, maybe the non-Germans don't know that, do you know Daniel Düsentrieb? So Daniel Düsentrieb, or, also the Germans know that from the TV2 Wiki, the Viking. There was always kind of like a light going on. Wow, I got an idea. There's a flash, an innovation. Now, innovation is not working like that. You can actually address and approach innovation very systematically. So it's not a myth, and we'll hopefully show later on that you can learn it. And I will. That's at least the goal of this class, that I give you some tools in hand, which you can use to actually identify innovation and then work on it. And that's maybe also very helpful to the people who want to get their PhD finished, because at the end of the day, creating innovation in your PhD is nothing wrong, right? So I don't necessarily want to go through all these things. I will provide you all these slides later on, so you can get a download link. That's why we'll jump over a lot of the charts later on too. I hope that some of you have actually done the homework assignment that I gave to you up front. If not, if you haven't done it yet, then do it till next time. I will also talk in a second.
According to this, Michael, I have a question. Like, what is EXO certificate has basically, I mean, it's really coming from the business and the economical part, which is my second job. So I was wondering what this has to do with research and science.
That's innovation, again, is invention times commercialization. If you're not able to actually make your product visible and make your product attractive to anybody outside your special area, it's not innovative. Then it's just something you use to write a paper, or maybe to get a PhD. But is that really sufficient? Is that something that really satisfies your research activity? Do you really want that to happen, that nobody gives a damn about what you did? So
I think if my product or my research outcome is that innovative that it can help people with dementia or ALS, or even help high performing people like from the FCM, maybe that they come back to the second league again.
Cool.
Then yeah, it will have some influence.
Okay, cool. That's again, we're not going into the details of your individual work yet, but we can do that later. But that's actually what I want to do. I want you guys to think maybe a little different, and maybe think also, and we get to this in a second, think what is the difference between incremental innovation and disruptive innovation? What we very often do in this world is that we create something minusculely better than what is around. So Beatrice, a quick question. I'm not picking you, but you're in the middle of my screen right now. So it's like the first thing I look at, right? So if I would give you a job and I would say, Beatrice, your job is to make this 10% better. Like you are a car engineer right now, and I tell you, you have to get 10% more horsepower out of it. What would you do? How would your approach be as an engineer?
Well, if I have to make something new, I need to understand, first of all, the clients. So
Yeah, but let's use this example. So you're a car engineer right now, and I tell you that you have to get the car 10% more fuel efficient. What would you look at?
the power of the car.
Well, you would look at maybe like what is going on. What is a key characteristics of consumption is aerodynamics, right? If you change the aerodynamics, you can get maybe fuel efficiency, maybe the whole fuel injection system, maybe the tires, if there's a resistance, right? So you look at these things and you said, where can I squeak 10% out? Now, do you think that's that difficult?
Well, as a car engineer, maybe no, because I just take the basic things of the car to make it better.
It's not that difficult because you know where the screws are you can turn. If I tell you that you need to do something 10 times better, 10 times cheaper, 10 times more fuel efficient, so not 10 liters per 100 kilometers, but 1 liter, what do you have to do then? Can you use what was already there?
No, I need to think new.
Yeah, that's exactly right. You need to think new, and that's the difference between disruption and incrementals. When you want to make something a little better, the Golf 3 to the Golf 4 to the Golf 5 to the Golf 6 car, you always use the basis of what you have already and try to improve it. If you have to do something disruptive where you have to do something 10 times better, cheaper, whatever, you have to think new. You have to think completely from scratch. And that's a little bit what we are lacking in healthcare and what we're not doing. And so this is also one of the goals that we try to get into this class, that you may want to think a little differently than you do right now. Okay, so this is innovation. That was the question. Please, just think about this. You don't, anything I teach you is not like, it's not the Bible what we do here, right? It's all, you can question everything and anything. But just think about this definition, this thing here with doing things differently or doing different things. That's a typical answer I get. But it's not really the answer of innovation. The answer of innovation is actually getting an invention times the commercialization. And only if you get it onto the market, people are interested and are willing to actually use it, it is an innovation. Now, I very often use is a patent innovative, by the way, Christoph?
Sorry, what did you say?
Is a patent innovative?
A patent?
A patent.
I would say in first place, yeah, but it also depends what kind of patent it is.
I have about 120 patents.
I saw.
I can tell you that I made only money with 3 of them. So that means 117 are kind of like laying around. Maybe there will be at some point in time, somebody will be interested in it. But at the end of the day, I say no, patents typically are not innovative as long as nobody cares and when nobody uses the actual content of it. And 3% or 2 to 3% of patents will actually have a commercial application, and that's pretty typical. So I'm not any better than the normal, any worse. This is about what happens. So a patent in general is not innovative, because it just basically describes an invention, but on whether this invention is actually ever used by anybody is not described in the patent. That is then the commercial success or failure of the invention. So please, even as engineers and scientists and medical doctors, please be aware that if things are not used and you just think about it and nobody cares about the content or use, it's not an innovation. At least in my opinion, it's not. Okay.
That's why research should be always focused on the practical approach afterwards. Like when you research the thematic background, you have to think, where can you apply it? Yeah,
but this is the difference between, and again, don't get me wrong, I'm not trying to get rid of research. Research is a very important thing, but in research is you actually have no commercial intent. So you basically want to do something to improve knowledge and to increase knowledge, but there's no commercial intent typically.
I would say differently, because like I'm grant-based student, and on a grant there is written that there should be a convincement or a combination or with industrial supplier that may can use or support of the theory that I'm researching in, and can then commercialize it.
That's what they always put in, but that's not really what they think. But I hope that at least would be something that people think more and more of. But in tendency, I have this one saying, it's called, you need to look for a painkiller for a burning problem. And what the researcher typically does, he has a painkiller, but he has not understood the burning problem yet. And I am trying to, at least with my team at the Inca lab, trying to work on identifying the problem first and then trying to find a painkiller for it. It's a different approach. And I'm not saying that one thing is right or wrong, but our approach is a little bit more commercial oriented. And that's why we're looking for understanding the problem first and then trying to find a good solution, while the researcher very often starts in the lab and does something without really understanding the problem properly. And particularly with respect to medical stuff, it is that we have to admit as engineers that we don't really understand how the medical doctor works. And that we only can find out innovation in that space if we really work closely with the medical doctor, understand the problem space, and then try to actually find a solution with that, or identify problems and then try to find a solution for that. So this is a little bit of what I'd like to get into you, and that's why I'm also very happy that I have a couple of medical students there, because what we found out too in our work is that we can get innovation done significantly easier working interdisciplinary teams, and we have different opinions about different subjects, rather than having the engineer opinion of how problems have to be solved, and then the medical opinion of what a problem is and how problems should be solved. So I don't want to go into depth in this one here. I just want to point out a couple of things that happen in medical space. So there's a lot of useless care, and Victoria, maybe you can nod your head on some of these things. You know, that there's 30% of care provided is useless. And these are statistics that come actually from Johns Hopkins University. So this is not something completely new. And so these are things that we should address and that we should actually go for. So how many of you are creative, just by the way?
All of us.
All of us, that's right, because creativity is not something you are or not. Creativity, everybody is creative to a certain extent, right? And I need to say this every once in a while, because there's a lot of people, Rutuja, I'm pointing at you right now. You know, every time I have Indians, lots of Indians in my class, then there is a lot of people who said, we are not creative. I said, why are you sitting here? Why are you studying? Of course you are creative. You basically live, right? And life, to sustain in life, you need to have creativity. So everybody's creative. So I just wanna make sure one more time that you know that and you work on this one. There's another Indian, so look at that. Now, we're getting now, I started off a little bit, but I now want to get to some of the administrative issues. We have a new guest there. Philip, can I see your face, please? So we're waiting for Philip. Philip is maybe getting a coffee. Or at least he has it on, but maybe he's not listening. So, but Philip should be a medical student as well. Now, here we go. Here's Philip.
Sorry.
Yeah, that's all right. I would prefer, and just because I do a lot of these meetings, just keep your video on. I know that people say that the stream goes down, but I like to look on your faces, and if you try to get bored or I see your eyes swooping off and go into your cell phone, then I may stop and do a break or something like that. So I typically look at your faces and look at on whether people are actually participating. It's very important. Just I'm a business guy, so I'm somebody who runs all kinds of companies and all kinds of ventures, and I do these meetings basically 8 hours a day, and I try to actually get people motivated and stimulated. You can only do that when you see their faces, you know. So just for the heck of it. So this lecture, I hope that you all stick with it, and I promise you it will be a very exciting one. Anna, can you say something about my lectures? And you know, if you have something negative to say, keep your mouth shut, okay?
I actually was never in a lecture.
You were never in a lecture, but Vutucha was in a
No,
lecture, right?
we did a summer
So,
school. So this I joined.
all right. Okay. So now I need to agree. We need to all agree on a potential day or dates. Now, what is in the book, what has been submitted is the dates you see here on the left. I don't really care. Those were planned for being on-site lectures. So now that we don't do on-site lectures, we can basically plan whatever you want, whatever we want. And I would rather do, if it's based on me, I would rather do 2 or 2.5 hour lectures every week, and then we maybe skip one if we feel like we should. And I would propose to do that on Fridays. So, but I'm also open to other suggestions. So.
Sorry, I have to say at first I cannot share my camera because then I really cannot hear you at all anymore. It's just
okay. All right.
And yeah, Fridays doesn't work for me because from.
But Friday would have not worked for you anyway then, because that was always planned for Fridays.
No, Fridays. I just wanted to give you the times. Friday doesn't work for me from 15 to 17 because I have my weekly meeting in my other company.
Okay. So anybody else have anything? So all would be okay if we do it 17 to 19:30?
That will work for me.
So let's do this quickly. Let's just change it right now. 1700 to 1930.
About early afternoon?
What was that? Say again?
What about earlier afternoon, on Fridays?
Yeah, in general it would work, but I can tell you that my time is not necessarily. I work, particularly in these times, I work with the Americans, so I have the time shift. So normally it would not work for me. We can every once in a while find an earlier date, but if it's 1700, we would need to start at 1430, right?
To me, it works.
Hmm?
To me, 1430 works also.
Yeah.
Yeah, not really, because I said like 15 o'clock my weekly meeting starts. So then we would need to start at 13 probably.
Mm.
I think for me that would also be difficult because I typically have meetings in the early afternoon.
Yeah.
So Beatrice, what do you have to do? You have to something very important.
It's okay. Also, 17.
So we leave it for the time being. Is that okay with everybody? I mean, at the end of the day, you are important, but I have to talk. I have to teach, so I have to be available as well. And I'm not sure that we always do 2.5 hours, because if we do it every week, then we have some time left, and I'd rather give you some additional some little homeworks, and then I let you go early. So let's be relaxed on this one. So shall we leave it for the time being? All right. Yeah. So I need to see. I never see Victoria. Victoria has disappeared on my screen, but she's probably somewhere else on my. Are you still there, Victoria?
Yeah, I'm here.
Okay, I don't see you on my screen. I only see 1, 2, 3, 4, 5, 6. So, all right. Next thing, we have gone through this already. So we have 2 medical students, is that right? And then a bunch of engineers, a bunch of scientists. This is very good because I like to mix you up later on when we do some teamwork on creating some interdisciplinary teams. I think that's pretty cool. I will go through in a second of what I expect you guys to do, or what is the outcome of this lecture. So I have set up a WhatsApp group. Did everybody sign up for this one?
Yep.
Okay. So we also, Moritz, Rutucha, and Anna are based in the InnoLab in the Zenit building. So whoever has not been there, it's on the 2nd floor. You're welcome to go there. We have all kinds of nice equipment there. So we have 4 or 5 ultrasound scanners, 2 endoscopy labs. We have X-ray systems, robots, and 5 or 6 3D printers and an e-lab and a mechanic lab. So one of the ideas is that we create quick prototypes, and maybe even we can create some prototypes for this part of the lecture. So you are welcome to come anytime there. Just make sure that one of these 3 people, Anna, Moritz, or Tucha, is present, and then it should be fine. Yeah. So this is actually part of this class, is that you work in smaller teams to a certain extent, and you actually try to create things. Now, I'm not saying that everybody has to create a real prototype. It could also be a written prototype with some drawings or something like that, but at least new concepts. Okay, so you can always reach me, right? So you have my WhatsApp, and use this mail down there if you need to get a hold of me. I also dropped you a link to the literature. Everybody received that as a Dropbox link? It's in the WhatsApp, right? So this is not, you don't have to read all of this stuff. This is more like for your reference, and more like informative. I will tell you when I believe you should read something. You particularly look, for example, the number 2 here, Siemens Future Surgery. That's nothing to read, it's more like to look at. But what is really cool about it is Siemens is actually providing a document of how they see surgery being done in 20 years or 15 years. So there's a lot of future orientation, and there's a lot of ideas that they need you to project forward. And so even big companies are doing this. So I will, every time I will point out if I believe you should read something particularly. If not, all these documents I believe are very interesting and important. So dive into it and look at it every once in a while, okay? Now we will talk about a lot of innovation methodologies, not right now, but we'll go through them in the sequence of this lecture. And particularly the one where it says empathy, it's on the top row, empathy defined idea. This is what we call the so-called bio-design principle of creating innovation. This is what we will mainly focus on. Also where it says identify, invent, implement, that's kind of like the same thing. And then we use innovation top methodologies from Alexander Osterwalder. Particularly, it's called value proposition canvas. Moritz is an expert on all these things, right? And business model canvas and all this kind of stuff. So you can talk to Moritz about all these things. But I will also so I will try to cover all these little aspects. You will not become an expert in this, but you will always at least be able to use it. And I want to use something novel that is it's called the Purpose Launchpad, and that it combines all the things to actually make valuable innovations. And these valuable innovations are based on finding, basically have a purpose, and then try to actually check on whether there's an abundance. Abundance is more like, is there a market behind it? And then also talks about the processes to get innovations in place. So again, something I think quite useful for people who think about products, processes, and in general about innovations to be put into the market. And this is if anybody's interested, this is the webpage. And we also will probably play a sci-fi game. A good friend of mine runs a company, it's called Sci-Fi Hive in Canada. And so we will probably create a science fiction story for the future of healthcare. I hope I can get him to actually teach it to us directly from Canada. So I'll have him here as a guest. And this is really kind of cool, because he used actually science fictions to project what you want to see in a certain domain, and also what kind of things need to be done to get to this point. And by the way, I will do together with him and Siemens, we will do a big challenge, a sci-fi challenge on the future of healthcare with about 200 attendees, probably in the next couple of months. And I hope you will still be there, and then you can participate in that as well. This is pretty fun. So I think that Rutucha can confirm that, and Anna, they were just part of the Siemens challenge, right? And we actually won. So I'm very happy about this. This was all these type of challenges talking about the future. They are quite a lot of fun, and you learn a lot of things about methodologies. Okay, so let's jump over this one here. Future. This is some of you have seen this before, but we will talk a lot about, when we talk about innovation, we'll talk about future. And future is something really interesting because there is, when you look at this cone of future, there's plausible futures, probable futures, preferred futures, and possible futures, but there is the one that you really should focus on, is the future that you would like to see. Because if you're not working on the future that you would like to see, or if you don't even think about the future, then you will have to accept that somebody else determines your future. Elon Musk with his ideas. This is, if you're okay with that, then that's fine as well. But please have a future-oriented mind. Project a little bit out in the front what will happen, not only in your particular case, but maybe also around you. Because only if you're part of this, you will be able to shape it. So we should be working on our preferred future. And I have some games that we will play later on. And I want to mention it already. Please don't put down, when we talk about future, what you think will happen. Always put down what you want to happen. What do you want the future to be? Not what you believe is realistic about it. Because otherwise you will do something realistic, but not something that will really create a personal value to you. And anyway, future is a cool thing because nobody knows what the future will look like, which also means that there's a lot of experts who tell you what the future will look like, and none of them really knows what it will be. So have a plan for the future and then be able to change the plan. If you don't have a plan, you cannot change a plan, right? And future is not something new in healthcare. This is a picture from the Doctor of the Future from Fritz Kahn. That's a German or Austrian. I think it's an Austrian. It was an Austrian doctor. In 1926, he already painted pictures of what the future will look like. And if you really look at that, you will see that a lot of these things are, yeah, maybe he's even ahead of our current time. But a lot of the things are in place, and there was certainly in 1926 something very futuristic. It was thinking about diagnostic, at the same time looking at monitoring equipment, has a remote workstation or a remote place where you can observe everything. So those are the kind of things that you need to do to actually plan for things that you want to develop in the future. He also came up with a human being as an industrial palace. It's a book. You can actually order that book. It's very interesting to read. To me, it's a little bit too much like every human is built the same way, which is not true. We're all individual people with our individual patterns. But nevertheless, from the functionality point of view, he's quite right about comparing us to a machine. So some rules and restrictions. Well, I can do this is all done for the lecture in person. So obviously, I don't see whether you play around with your cell phone, and hope you don't do it. Hope you have some attention span towards me. If you feel bored or anything, you can always tell me too that I should continue, right? If you have a feeling that you don't want to listen to this, what I'm saying right now, then tell me, put it in the chat, and then I will just forward. I'd like to high fives you. You will work in virtual chat rooms at some point in time. So let's just all be very nice to each other and all congratulate and all work together. But most of this, what I'm just pointing right now, is again done for an on-time presence. So just a quick word so you at least know who you're dealing with. So I am an entrepreneur, basically. I've started all in all 34 companies. It says 25, but it's 34. I actually measured it. I'm a very outdoorsy person. That's why I put the ski picture of me in there. I think it's kind of cool. So you should think that I'm a cool guy. I'm wouldn't say really old guy, but I'm mid 50s. So I'm still feel very fit though, I have to say. And my really passion is that I like to motivate people to think innovative and also think as entrepreneurs. Now, I'm not saying that I want to create entrepreneurs in this course, but I would like you to actually think a little bit like entrepreneurs, think a little bit forward looking. So I have a lot of patents. I said that already, and I have a beautiful dog. My employees in Magdeburg know the dog, but I'm sure that it will come because it gets bored. The dog every half an hour he comes and wants to get some attention. So, any question? Oh, this is the most important thing. I have a master in brewing and distilling, so I love to brew. I have a brew machine at home, and I have a distilling machine at home. So I do this stuff. I'm not an alcoholic by any means, but I like to actually create some things that you can drink later on. And I've at least convinced Moritz to be part of the Untapped group now. So if anybody wants to have a really cool social network that you can then use Untapped. That's where you rate beer. And so we have a group of people that rate beers all the time. So every time we drink a new beer, we put a new rating in there. Futusha, are you part of this too, and Anna? Not yet? All right, you will be though, right? And when we are in Magdeburg, so when I'm in Magdeburg, we always meet at the Brew Cow, at the local brewery. So if we should actually make it this year or early next year that we get together, that's typically the place we would meet. Okay, now also something I would put down when we would meet in person, that you would basically introduce yourself to each other and talk about things that you would normally not talk about. It's everybody knows you're a student, but it's very interesting if you do this kind of stuff. And again, let's keep that open for maybe doing it when we really meet each other, that you put things down that you really love to do. And you will find out on whether people have the same passion. And if you have the same passion, you typically have a much better way to talk to each other. And so it typically helps to get together. So I'm just, at some point in time when you also meet maybe at the InnoLab, you should do that. Okay. So let's try something first, and you are the guinea pigs right now. So I've not done that yet. So let's go to my, let's stop this one and let's use a different screen right here. Now, hold on. Where's my, here we go. So you should see my, let's try, oh, sorry. Okay, so where's my presentations? So get out your cell phones, please. And let's try this. So now we play it. So open up menti.com on your cell phone. And it should ask you for a code. And then put in this code. 992476.4. Everybody has it? I should see when people come in.
Repeat the code, please.
You should see it on the screen right there.
Oh, yeah.
Up there. 992476.4. Actually, I'll try it too, so I know what we're doing about. So menti.com. And then I put down 9924.764. Okay. I should actually see you guys. All right, fine. So just enter this and see what comes up. Maybe I should put this.
Can you see how many people voted already?
Yeah, down there it says 5.
Okay. A short question, where's the difference between health insurance companies, providers, and healthcare providers?
Healthcare provider is a hospital.
Oh, okay.
Yeah, so health insurance is like the payer, basically, the one who pays. Now, it's very interesting. I've done this with like when there's 100 people on there. And let me just ask one of Morris, do you have any idea what did you use? What did you pick? What is the most
Health insurance companies and healthcare providers.
why would they be the pluckers?
Health insurance companies, because they decide what is being paid. So whenever you want to create an innovation that is used in the clinic, you have to think about if it will be reimbursed by the insurance companies.
Maybe I did something wrong too. Maybe I should have explained what health disruption I explained, right? Something that is really getting things much cheaper. What do you think democratization means? Does anybody know what I mean with that? No?
Make it more available, or make it available for a larger amount of people?
Basically, make it available to everybody on the same scale. So if you have a lot of money, you should not get a better treatment than if you have no money, right? Democratization means you basically have all the same access to advanced healthcare. Now, in reality, sorry to say, Victoria, but the doctors are the main blockers. Why? What is a doctor? When is a doctor getting paid?
If you treat somebody.
Mm-hmm. And if you don't treat somebody, does he get paid?
Nope. I mean, he gets paid his standard loan, but
no. If you don't have any patients, then you don't get paid. So what about the health? What about a hospital? Does a hospital make any money if they have no patients?
Probably not.
What about a pharmacy? Is the pharmacy getting paid if you're healthy?
Nope.
No. What about an insurance company? Not an insurance company gets always paid, right? Whether you're healthy or sick. An insurance company is something an insurance company is something that basically covers the chance that you get sick, and you want to be sure that somebody pays for your bill. But what is the healthcare system in reality? Is it a healthcare system or is it a sick care system? Sick care system meaning you are actually only getting money on everybody only benefits from people when they're sick. Isn't that the case with the healthcare system?
For Germany, I would say, yeah. Like when people are sick, it's more expensive for the health insurance. But there is, like in Swiss and other countries now, coming up systems when you are healthy and you have a good life and treatment, that you can monitor this via apps, that you pay less.
But still, health industry, we call it the health industry, right? The health industry in general only makes money when you get sick, even in Switzerland. How about the US? That's a big industry. So if you, for example, make something that prevents you from getting sick, then nobody really in this current stakeholder system makes any money, right? Just think about this, and that's why I'm very focused to a certain extent that you need to think a little bit about economics. You need to understand if you want to bring innovation into the market and you want to make sure that people are interested, and you need to also understand how people think about it. If I have an MRI that I can now sell for 50,000 euros instead of for 1 million, would that be beneficial to a radiologist? Think about it. So pretty much every little practice could buy an MRI. Would that help the radiologist?
No, then they don't need a specialist anymore to observe his MRI pictures.
That's one thing, yeah. And what if the cardiologist now has an MRI? Would that be helpful to the radiologist? No, because the cardiologist doesn't need the radiologist. He would do it himself or herself. Every time I say him, don't get ladies here on the board, I mean bisexual, I mean he or she, right? So no, they don't. So always think about making things a lot cheaper is not always beneficial to the current stakeholders. It's a very important message. And making things available is not always beneficial to the current stakeholders. So just by arguing, I will be successful in the market because I'm cheaper is not necessarily true. Again, there's a lot of examples for or against it, but be aware that that could happen. I hope you still have all the Mentimeter over, because there's a second one. So what I'd like you to do now is, and then we're done with this one, I would like you to put down, and let me explain the question first, not that we do it. I would like you to put in which is the most promising technology that will increase longevity. Longevity is how long do you live? So not 85 years on average or 80 years, but maybe 100 years. What technology do you believe will have the biggest impact of increasing the lifespan? Any questions on this one? Everybody knows what AI, ML, DL, that's artificial intelligence, machine learning, deep learning, big data. Robotics is clear. Blockchains, you may not exactly know what that means. That's basically just making sure that the data exchange is secure and that it's validated. Tell me also if it's later on, if it's difficult to fill out, because obviously you're my guinea pigs right now, and I'll try to check all these things.
I don't really get how to use the low or few, because, for example, I have my preference. So I need to put a preference for each of these things, or I just choose one?
Yeah, no, for everyone, like CRISPR, if it's low, you can put down, no, you don't believe it's, then you put down a 1, right? And then you go to the next one, 3D printing, you think it's a little higher. And so for every one of them, you just move the slide, right?
Yeah.
Yeah.
But the second slide is, I think, about if we think for how many people this will make a difference, or how many people will benefit from it.
Yeah, let's not ask too many questions, Moritz, but you're absolutely right. But let's just be, what do you think? The essence is, the question is, what do you think is the most important technology for increasing your lifespan?
Okay, so we don't move the second slider.
Oh, okay, sorry. You're absolutely right. Now you have to move the second slider. Second slider basically says, what do you, I'm sorry, I didn't even understand my own question. So is it for very few or for everyone? So is it democratization or not? Like artificial intelligence, just to be quick, is probably something where you say it will benefit everyone. Robotics, well, will there be that many robots around? Probably not, right? So only very few people. So when I look at that, we have only one person who actually put it in. So
sorry, I have a question. What does blockchain mean? So data security exchange.
What blockchain? So we'll talk a little bit about blockchain, but right now everybody talks about data safety, data security, and data exchange. And blockchains is a technology. It's basically bitcoins. You know, Bitcoin is a blockchain technology. It is a distributed network where you make sure that there's no data manipulation going on.
Which is also important for further, like for healthcare telematics, when you want to do this at home with your, like, let's say, really private data.
Okay, so safety of your health data, of personal health data.
Yeah.
That's the most important thing. Okay, bye.
So interesting enough, there's nothing really, you know, pointing out to the, normally would be interesting would be now everything that would be in the first quadrant, right, on the top right. That would be ideal. Now, this is your opinion, and that's good. And maybe we'll do this again when we are finished with the lecture, not today, but maybe in a couple of times when we talked about technologies, and maybe that will change. So maybe I'll make a screenshot on this one, and I'll try to actually compare that later on then with what we come up with later. I personally believe, this is just my personal belief, is that it's probably going to be CRISPR and AI, those two technologies combined. CRISPR is something, I'm giving you this information right now, there is 50,000 known diseases at the moment, and 32,000 of these 50,000 have a single gene defect, are caused by a single gene defect. So if you really think about this, a single gene defect, could you not also imagine that if it's only one defect and you identify that you can fix that? And that's what CRISPR can do. That's what it's basically a gene editor, that you can fix this potential problem of a disease that will come up. Could you imagine that in 10 years or 15? Nodding, shaking.
I have a question related to this issue. Don't you think that this is maybe a little bit too simple? Just changing genomics, because I mean there's a huge influence of lifestyle and stuff like this.
Absolutely, you know, you're absolutely right. It's always a combination of things.
Yeah.
But you need to start. You need to start with it. I did not say that it's the only technology, but I say what is the biggest effect that a technology will have. And I'm
at what
not
point of age CRISPR sets in, like before born, like still with the baby cells?
No, there's some ethics issues with that.
50 years old.
Yeah, there's ethics issues with that too. So I'm not sure that we want to go into ethics, even though I have an ethics canvas later on that we can discuss, because ethics is something subjective. And ethics will also be something that will probably change over time and will be adapted to whatever new technologies are. Give you a quick example on that one. I 2 or 3 years ago, no, it was actually longer ago, when I was teaching in Munich at the TU, I was actually asking about innovative projects, and some Indians came up with a gene editing machine or clinic. So you could take basically you know, whoever you wanted to have from the male and the female side, and kind of like create your wish baby. And that was actually for that society, for that culture, was okay, was accepted, where all the Europeans said, oh no, don't go that way. Ethics and moral is something that is subjective. It's not something which is everywhere the same. And I think when we talk about technologies, and it's a very interesting aspect, we probably need to at some point in time discuss on whether we need to have some different rules and guidelines that control our work. If you talk about AI, and people who are actually working with some AI, they know that the quality of the data input is very relevant. And what we have seen in the US in some of the AI results is that for some of the data, they were using predominantly white male data points, not purposely, but that's probably just what they had, and they did not think it was that important. And then they found out that for female Black people in Africa, it was not relevant at all. It was not working at all. So this is an ethics and a moral issue that you need to consider with your data points. But you need to also be aware of all these things. And it's also why engineers and developers have a responsibility in the future. So anyway, this was just an exercise, and I just wanted to try this out. And I'm going back to the normal presentation again. Here we go. I have another exercise for you that comes in a second. So, oh yeah, it comes right now. So let's do this one too. So now let's open Kahoot. And you need to open Kahoot. What is it called? You need to open, just wait 1 second. You don't see my screen, right now? This one here. So you need to put down, you need to enter Kahoot.it. Do you see the screen? And then put down this game pin. I think that's all, right? So we're 1, 2, 3, 4, 5, 6 we should have. Very good, so let's start. So in all low-income countries today, how many girls do finish primary school? Now you have to push on your cell phone either red, blue, or yellow. So what do you mean? We need to have 6 answers, right? Next one. Next, sorry. None was right. Where does the majority of the world population live? There should be a picture. You cannot see. Oh no, that is not. You also see that the quicker you answer, the more points you get. It's only 2 more questions, so you got it over. Yay! Let me make a picture of this one. I like this a lot. So, what have you learned from this one? What have you learned from this one?
The game. From the game, you mean?
Yeah.
That we have to think faster.
You have learned one thing for sure, that you don't really know the world, right? And that's actually one of the and don't worry about it. It always comes out with the same. It's that people are actually completely misjudging what their world is like. So what you have done is an ape, just somebody just doing a 1 out of 3, right, would have gotten at least 2 to 3 questions right. None of you had more than 2 questions right. So which means you don't really know anything about the world. If you do this, interesting enough, in industrialized countries will always be worse than developing nations. Why is that? Because the industrialized nations, the US, the Europe, they always think we're so far better in our nations than they are in India. Rutuja, how many questions do you have right? Just 1 or none?
1.
1. It is a shame, to be really honest. And I'm not sure that I was really any better when I did that. But I want to show with this one is the world is actually not as bad as we think. And it's actually developing quite nicely. But sometimes we focus on the wrong problems. And we believe in a lot of ways, we believe coming from the nations that we are in right now, that we're so far better off than anybody else is in this world. And that's just simply not true. So I think I'll go through this one here. This is roughly what we're going to do. I'm getting to the point where we can stop for this. I just wanted to give you an introduction on what we will do. We don't have to look through this in detail right now. I will come back to this later. I will also have something on what you should do if it goes on. So what I want you to do is I want you to read some of the literature that I provide you. So I gave you something to read. I don't know who actually read it. Anybody read it? The paper that I gave you?
Yep, I read the paper, but not to watch the video. Like this 1 hour was too much.
Yeah, you don't. Again, it's only if you're really interested. In the paper, is pretty much the same thing. Then I read what I wanted to say with it. And I have obviously a lot of problems. Obviously, with some of my colleagues, they believe that I'm trying to change things too dramatically. I'm not trying to change anything. I'm just trying to make you guys aware of certain things. So I have 2 individual assignments. You don't have to read them right now. We'll get to them later on. And there will also be a team assignment where we have, how many do we have now? 7, is that right? 1, 2, 3, 4, 5, 7. So we'll do 2 or 3 teams, probably 2. And I have also some bonus assignments. A bonus assignment means, so not that you can sue me later on for being an unfair professor. If you do them, if you don't do them, it has no effect. If you do them, you can improve your grade. I'm not entirely sure how many of you are actually interested in a grade anyway. In this course, nobody will fail and nobody will get a bad grade, because I hope that you guys will be excited about doing some of the exercises, and that all will be good. I will do at the end, that's why I introduced this Kahoot to you. We'll do a little online test with 20 questions. And I thought that was kind of cool with Kahoot. Do you like it? The music was a little annoying, right? But I can change that. So I will do some questions, and they are certainly not that difficult, or not as difficult as these ones here. So more obvious. So what we do in the team assignment, we'll work on what we call unmet clinical need. You may not know exactly what that means right now, but what I'm looking for, that you work on something that is at the essence 10 times cheaper, 10 times faster, or creates 10 times more users than at the moment. Something really massive. And you don't obviously have to create a business plan or business model out of it, but you have to work on together in a team when working on a solution idea. You hear my dog in the back? I need to shut the door here. I think the dog is hungry. Okay, and so you don't have to read any of this stuff, because we'll go through these in detail, what you have to do. And I hope you will be able to use some of the tools that we present you also later on for all kinds of innovation ideas that you have yourself. Now we have nobody from the MSc department, so maybe you, Beatrice, you are from the graduate school, right?
Yes.
Okay. Christoph, you're from the graduate school too? Christoph. Christoph is not there. Anyway, so
I don't know what is graduate school in this meaning in German.
I didn't hear what you said.
Well, in what contents do you mean graduate?
No, sometimes when we have informatics students, or we have medical engineering students who are taking this class for their master degree, and then you have to do a different type of credit unit.
Yeah, no, I don't need any CP or anything.
Okay, so then who cares? Maybe we'll do them anyway, these ones. Okay, lab, I have said that, go to the lab. So you had Holger on there. You also have the address of Axel Böse, who is the chair manager. You can talk to Moritz, Anna, and Roducha about this. So I would really advise you to just go there one time. Beatrice, where are you? You are in the Zenit building as well, or you're in the Lin building?
This is the name.
Okay.
He's in the A2 for Christoph.
What is it? I didn't hear.
I said I'm in the DZ and E2. So it's
I have no idea what that is, but that's all right. So you'll get together. You will make sure that you actually talk to each other. Okay. All right. So that's what I mentioned already. So this is the core principle of this class, is identify. And what do I mean with identify? I mean identify so-called unmet clinical needs. How do you identify unmet clinical needs? Anybody have an idea?
We can go into the hospital, for example, talk to surgeons, and they will tell us some problems that they have.
Typically, you will not find an unmet clinical need if you sit in your lab and with a closed door. You need to go out and actually inspect and work within a clinical environment to understand clinical problems. So once you identify the issues around it, you can start ideating and inventing around this. So what we normally do is we don't think too much about the quality of the idea. We create lots of ideas. So it's better at the end of the day for this type of class that you create lots and lots of ideas, and then you later on try to validate them. And then the subsequent part would be implementing. So this is something Stanford University teaches. There is I have it here actually. Not sure that you want to read it. This is a big book, right? Biodesign. This is where that comes from. And it's actually a very cool book with a lot of nice examples. Do we have some, Moritz, do we have that at the InnoLab, that book?
Didn't see it so far.
Okay, I think I have one there actually. No, I do have one. You have to look in my bookcase. So if anybody wants to read it, this is in the InnoLab too. You can actually have that and look through it, and maybe actually take it with you, and as long as you bring it back again, right? And I think the library has a couple of these books too. We will do a little bit of a variation from that, but this is roughly the principle that we go for. And what we are trying to look for is what I said before. We're trying to look for disruptive technology. And maybe a little definition of disruption. I said something before. To disruption is something where you basically question and do something completely new to what is done before. And you are actually trying to improve what is done right now by a massive factor, not by 10%, but by a 10 factor. Now, there's some examples that we can show you. For example, we have just created a new conscious media injector for MRI and CT applications that is a factor 1,000 cheaper than what is done right now. That doesn't mean it will be successful, but this is something where and that's why getting to this democratization idea again, if things are expensive, not everybody will be able to use them. If things are cheap, everybody will be able to use them. So price is something that is in research not that important, but I believe in real life it is extremely important to look at, reducing cost and making sure that it is accessible to everyone. So here's the definition on incremental and disruptive. And very often what you see, Beatrice, you're working on MRI, is that right?
No,
I saw from somebody who was working on MRI, or was I wrong with that?
Christoph again.
Oh, you. So when you look at MRI, that's very interesting. I'm an MRI physicist, so I'm doing this for over 30 years now with MRI. And what you have seen in MRI is a continuous improvement of image quality. But have the systems actually gotten any cheaper? Any less big?
Not really.
It's all the same still.
It just takes longer. Like the more deeper you want to watch, you need like longer time, or you need like phase correction that it's not moving, and so on and so forth.
Yeah, that's incremental improvement. So they get always a little better. Image quality gets better. The acquisition speed gets reduced. Maybe you can see a little more, but at the end of the day, there has not been a massive disruption. The MRI system is still at 1 million euros.
True.
1.5 Tesla, right? And do you believe it is possible to build an MRI for 100,000 or 50,000? I mean, I know, Moritz, we can say that we can
build in the future.
We can build a CT scanner for 10,000 euros. That's not a problem. Now, if you build a CT scanner for 10,000 euros, do you think Siemens can maintain their business model?
They have to come up with another innovation.
Let's calculate the whole thing through. Let's assume the MRI price is 1 million euros, right? What do you think the profit margin of Siemens on the MRI is? How much do they make? What do you think?
Taking into account like all the development that they put.
Just tell me a number. Just don't make it complicated. Tell me 100,000, 50,000. What is it?
60%.
How much?
60%.
I think you're very generous with the profit. I think they make probably at the most 10%.
Okay.
So how much is 10% of 1 million?
100,000.
That's correct. So now you have an MRI for 100,000. And let's assume they make the same profit margin, 10% again. How much do they make then?
10,000.
10,000. So how many more systems do they need to sell to come up with the same profit margin?
10 times more.
10 times more. Do you think it's possible?
I don't think that the request is that high, no.
Possibly different, but that's not their business model. Their business model is to go to a hospital and sell 1 MRI scanner, not 10.
No.
So what I'm trying to say is making something really cheap is not necessarily maintaining a business model of a company like Siemens. They are really not interested in having cheap MRIs out there and cheap CTs because they could not sustain their current business model. They know they're working on it. I know that for sure because I'm also a consultant to Siemens, so they pay me for for getting involved in some of the things. But they are trying to delay this process as much as possible, as long as possible.
Same what the car industry is doing with putting the electromotor like.
Yeah, they have waited a little too long in Germany, at least. Possibly have waited too long, so we'll see. That's also why you need to be up on understanding what kind of technology could come and roll over you. And that's what we call, and that's what you will find out when you go through this exponential technology model. That's what we'll teach you. They will teach you about these 6 Ds that come up. Anybody know already what the 6 Ds are? We'll get to this later. So if you don't know, it's not a problem right now. Don't worry about it. But there's always a phase, a technology phase that's called disappointment. And a disappointment on a 100,000, on a 10,000 euro CT versus a 250,000 euro CT, what would be the disappointment on that 10,000 euro CT? Shitty image quality, very slow acquisition speed. So why would you do this CT? Just because it's cheaper? It's really, really bad. But can you imagine that you get the image quality up and the acquisition speed down over time? So if you miss this technology step, you may be completely missing out on a novel development. And that's why these big companies are very interested in always monitoring what's out there and who's doing what, but they're trying purposely to delay certain things. I'm not blaming them. I would probably do it the same way because they may have to maintain their business model right now. So have that in mind when you also think about new ideas. So what happens when you hear that the medical system and a hospital needs to be digitized? What does that mean, Victoria? Have you heard that we are really doing too many things analog and we need to digitize and we need to put a digital effort into the hospital? What do they typically mean by that? How do you write a report?
My personal opinion about digitize the medical the telemedicine, maybe.
Yeah. So what is telemedicine? What is actually telemedicine? What is the difference between telemedicine and normal medicine? What's the difference?
We have maybe, for example, the smaller hospitals.
No, just look at it from the provision of services. So you have a patient, right? On one end, and you have a doctor on the other end, right?
Mm-hmm.
And in between, there is some weird form of communication link, wireless, cell phone, whatever. But it still is the connection between a patient and a doctor, right?
Yes.
So you don't have to go to the waiting room, but other than that, it's the same thing. And you don't shake hands. So digitized, that's digitizing an analog process. Or you basically have a system where you say, okay, the patient has following da 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 da. You basically, dictate your report, and it will actually print it out and be automatically put into the report system rather than doing it by hand or typing it. That's also a digital process. You make an analog process digital. But is that really improving medicine? It may actually improve some workflows, but does it actually advance healthcare or makes it better than it is right now?
Yes, because you can help the patients quickly.
Yeah, that could be, but the doctor is the weak link is the doctor, right? Because the doctor still has the same amount of patients. Does the doctor actually see more patients because he has a connection via digital? He still has only 5 minutes per patient. 12 patients an hour, in 10 hours, 120 patients. It's the same thing. It's for the patient maybe a little better, but does the medicine improve by that? Well, think about it. Maybe it does, maybe it doesn't. What is a problem is that we have so many more tools right now that are not finding the way into the practice. If you talk to a doctor right now and say anybody knows ADA? If you don't, Google ADA and use an app. It's basically a medical app. Victoria, that would be interesting for you. It's a medical app, and you basically put in your symptoms. Hip pain. What hip? Left hip, right hip. You put out right hip. Then it asks, is that the only pain you have? Or maybe you have pain in the foot and in whatever. So it uses AI to basically evaluate your input and then gives you an advice. What would a doctor do differently on a telemedical connection? Anything? Probably not. He would also ask questions, right? And it would come up to a result. So why use a doctor? Anybody give me an idea? Why go to a doctor? Why have a telemedical connection to a doctor if you can do the same thing with the software, and probably faster, cheaper, and with less time? If you don't have an answer, this is also an answer. We don't know. It's not clear. So do you see what could happen with the whole medical profession in the future? But is that being introduced into the system at the moment? Probably not. What we're trying to do is we're trying to actually make a traditional medicine better rather than to take the tools that we have and create a new medicine. This is what that says. And I think what you should also look at is that we should be able in the innovation space, not only make traditional medicine better, which is incremental, but also try to actually use tools, technologies, devices to completely redefine how medicine is being done. Now, to the medical students again, Victoria, are you learning anything about technology in your studies?
No.
This is pretty sad, isn't it? I mean, at the end of the day, medicine will probably be the thing that will be most affected by new technology developments, but the medical students are not learning anything about the potential of medicine. And that's also when you remember the first question that we had, who is the biggest problem space and the biggest hurdle in healthcare implementation and new technologies is actually the medical profession, unfortunately. And I hope that, some study programs in the world will be adapted and use more technology approaches. And in the US, they do that to a certain extent, in Switzerland as well. But in Germany, we're unfortunately still teaching the same stuff than we did 30 years ago on medicine. I see some shaking heads, some questions. So tell me what you have learned that is different, that is new from the last 10 years in your medicine education. I'm not talking about later on, in your studies.
I mean, I haven't been 10 years ago in a medical class, but I think research has improved, and the understanding of disease is now really more in a deeper way. And so I think maybe the kind of education hasn't changed, or the focus, but there's more and more to know, so more and more knowledge to learn.
But think about what you just said. You said there's more knowledge, but is your study program at becoming a medical professional, has that actually been taken into your curriculum?
Sorry, I don't really get the question.
Is that part of your teaching curriculum? Are you aware of all these things that happened?
No.
See, that's what I'm trying to say.
Yeah.
I'm not. Of course, you're absolutely right. There's new, but the education of the medical doctor is still the same than 10, 15, 20 years ago. And this is actually something where, and the engineers for that matter are also, we're not teaching, they don't teach us anything about how medical professionals work. So we have a gap between engineers that could help medicine to become better and medical doctors to actually adapt technologies to accept the fact that it can get better. There's a big gap.
Maybe I can comment on this. Mm-hmm. I think it's for both cases, it's really a problem that you can't just add stuff to the list you want to give to the student. So because then you would need 1 or 2 years more for the whole study.
But this is Germany. I don't know if you remember the discussion we had with the 12-year high school and the 13-year high school. They were gladly willing to reduce the number of years, but not the content. And you need to just get rid of certain content space, and you have to ask yourself whether everything you learn in your medicine study is actually necessary, or everything that we learn in engineering is actually necessary. So, and from the engineering perspective, which I can judge significantly better than medical, I would say that a third of what they teach us in engineering is completely obsolete and not necessary. I would rather focus on soft skills, on problem solving, on innovation generation, than talk about how on whether I really need to know exactly what 2 transistors in a sequence, what they really do to each other. I'm not entirely sure that's not relevant anymore. Moritz, would you agree or disagree?
I agree.
I grew up with transistors and all these vacuum stuff, and I have no idea why people still have to learn this. It's completely irrelevant. Anyway, so I'll just jump over a little bit here. I think you can read that later on if you want to. I'm a big fan, and don't get me wrong. Don't tell that Michael is always teaching about entrepreneurship. I'm a firm believer in entrepreneurship. I believe entrepreneurships are the ones who will solve problems. It's not the big companies who will solve problems, because the big companies have a different agenda. Remember what I just said, like they need to maintain the MRI price segment at 1 million for a long time. Otherwise they will be running out of their business model. So they're not necessarily interested in that. And entrepreneurs will solve some of the major problems, so that when you identify a problem that we hopefully will do, you cannot rely on a big company to actually solve this problem. You may have to do it yourself. And large companies, if you have anybody worked in a big company before? Like in the, which one was that, Moritz?
Lufthansa in Frankfurt.
Oh, okay. So in general, I'm again, a lot of the things that are put down, that they're not always right for every company, but in typically large companies are really not good at innovating in the disruption space. They're really good at making things work. They are very good at incrementals, but they're not good at looking at the latest technologies and implementing that in the market space. And that's because they don't see a market for it yet, and they believe they cannot make money with it yet. And so that's why typically these kind of innovation come from small companies that are then being bought or acquired by larger corporations. I'll jump over this one here. I have mentioned many times, I think the healthcare system, we need to do something massively about it, because what happens, and the US is a very good example for that one, that GDP, gross domestic product, in German it's called Bruttosozialprodukt, is the healthcare is taking more and more money out of this system. So in the US, it's increasing. So it was 5 years ago, it was 12, 13%. Now it's 15, 16%. It will always increase. Now, is this good or bad? And tell me why it is bad, if it is bad. Beatrice is gone now too. Anybody have any idea? So is it bad? If things get more expensive, is it bad? In general?
Definitely, yeah.
I'm not sure that's true, because at the end of the day, you know, there need to be an economy around it, right? People are employed in healthcare, so it's not necessarily that wrong. What's wrong is if healthcare increases by 5% and the gross domestic product increases by 1%, then you have a big gap. More and more is being basically invested in healthcare, will take up a lot more of the things that are being done in the other segments of industry. If the price increase of healthcare would be the same than the gross domestic product increase, I think it would be okay. It would always stay at the same level, right? Always 10% would be invested in healthcare. But it's getting more and more. And that is really a problem, because what you work is more and more for your future healthcare expenses. Will be less people employed, so it will be more again. So we need to do something about this. It's in the Americans, you see that spend about almost $10,000 on healthcare per person per year. If you know that the average salary in the US is only $35,000, you see already how much money is being spent in healthcare, and that is certainly not healthy at the end of the day. So this is Victoria, I don't want you to necessarily, are you still there, Victoria? You're still not on my...
I'm here.
You're here. This is, I think you're the total exception to this, but this one here is from the JAMA, so a very, very well-respected journal. It says, patient perceptions about their physician in 2 words. So what does the patient think about their doctor? The good, the bad, and the ugly. Do you see any positive statements? So it's not, I didn't make that up. They asked, I don't know, 10,000, 15,000 patients or 20,000, said, what do you think about your doctor? And that's what came up. Now, if you see this one here and you think about innovation, what would you do? Cluster some of these words: rushed, hurried, busy. They're all the same, right? They don't have any time. That's what it means. So you have to give them some time back. Now, why are they arrogant? Because they went through 7 years of medical school and 5 or 6 years of specialization and make a lot of money, right? So there is a lot of things that are in there will already lead you to some innovation ideas that you could have. Okay, but in all, it's not a very positive statement. So I think that's also another reason why healthcare needs to change to a certain extent. This is something you can read later on. We don't go through this. I highlighted some of the items for you. It's assessment of inpatient time allocation among first-year internal medical residents. So what do they spend their time on? They don't spend their time with the patient. They spend their time on filling out documents, forms, discussing, ordering things, whatever, but not with the patient. Now, are you guys becoming medical doctors because you want to fill out forms? So also innovation. Every time you see something that you don't like is a potential for innovation, right? Okay, more mistrust in science, a threat to the patient-physician relationship. There's all these documents out there, and if you read them, you're to a certain extent shocked, but you also know what should be improved. Is to look into the future. And I can really, really recommend this book. So if people have, I have it here as well somewhere, Deep Medicine. This is a book from Eric Topol. If you are in this space, I would advise you to sign up to the blog of Eric Topol. He's works at the Scripps Institute in San Diego. Is a cardiologist, very well-spoken person, and somebody who's really up to date on all the technology developments. He hates Trump. That's good. So we are that one we have in common. And this book is awesome. If you read this, this basically describes where will medicine go to with using new technologies in the future. So highly recommendable. We don't have a book of this one either in the InnoLab.
I don't know, but Thomas has one which I just borrowed. Okay. So I think we can hand it around maybe.
Oh, I have it here. Here it is. So it's a really nice book. It's also it is very readable. So I think it took me like a day and a half to actually read it. So I would really recommend for particularly the people who want to work in the interface of innovation between medicine using particularly AI. He's very much into the AI part. This is a really, really highly recommendable book. It's really, really nice and readable. It's not that expensive either. I think it's $20 or something, 20 euros. Let's just see, $32 it costs, so whatever. So he's basically saying that, we need to improve the relation between the patient and the doctor. We need to give the doctor some time, and we need to put him as a guide to the patient's destiny. And we have to use technologies that are or will be available in the future to get rid of all these excessive diagnostics that we do, excessive treatments that we do, and focus on evaluating the patient's problems quickly. Okay, so this one we can go through, this one we can go through too. This is just something I want to highlight, and we have started the discussion already. Please look at the left side, and you tell me, it doesn't matter where you come from, whether you come from an engineering perspective or from a medical perspective. Actually, let's look in the middle one. Do they teach you creativity at your university? No. Do they teach you communication skills? Do they teach you on how to work in teams, collaborate, interdisciplinary approaches? So far, I've not seen anybody nod their heads. They've always been only the shaking parts.
Let's say you have to go and find it yourself. They don't make it mandatory.
Do they teach you to be curious? Or to generate a self-initiative, to actually come out and do things on your own? So this is the problem, that the 21st century will actually require completely different skills than what we teach. What's on the left side, literacy, numeracy, that's what you get taught at university. What the algorithms are, what the transistor looks like, what the medical anamnesis looks like, that's what they teach you, but they don't teach you any of the other skills. So I hope that this class that you're attending right now at least goes a little bit into this segment, because that's what I believe is significantly more important in the future than any of these detailed skills. You can acquire those later on. You may even have tools to do that, but if they don't ever teach you to be creative or to work in teams on critical thinking or problem solving, you will have an issue in the future. And that's why I also believe that universities will have to change their business model. In Germany, nobody pays anything for tuition, but think about the business model in the US, where you pay thousands of dollars to attend. You would pay for this class, every one of you would pay probably $6,000 to $7,000 just to attend the class, on whether it's online or not. So you would basically wait till Michael Friebe, who is recording this, puts it up on the web and you listen to it. So what do you need me for at the end of the day? So these things will need to change, and we will need to actually work with you on problem solving skills rather than on teaching you exactly how a transistor works. You can actually have an online course, and probably somebody who's better at didactics can teach you much better than I can. Okay, so this is, I think, is the future. Also, there will be a huge effect on the teaching, and I think it will also be an effect on the medical teaching. So there's a lot of saying about it. And if we go to these big companies, they don't necessarily want somebody with a PhD in physics. They want somebody who is able to actually solve problems and has a combination of soft skills and scientific skills. So this is what we call a T domain. I'll go through this in a sec. All right. We don't go through this right now, but what I would like you guys to do, this is not a homework, but please think a little bit about any problems that you have on your mind in the medical space, and maybe shortly define this on some sticky notes and maybe have them ready for next time, because I really think that's a really good starting point for innovation, to identify what is very obvious not going in the right direction. Okay. This is what it normally looks like. I do this very often in seminars, and you only spend like 5 or 10 minutes on it. And I say, put on the left side what you see is wrong, and put on the right side what could be a solution. And it's amazing what comes out of this. You know, in a setup with 20, 30 people, you have then 40, 50 ideas, and most of these ideas are too far-fetched or too far away, but nevertheless, they're a good starting point for working on innovation. What is this?
Boxing.
Boxing. A box fight from above. This is something I use that every once in a while. People who know my lectures have known that it's something called droodles. And the droodle is something that brings you away from your normal thinking process and just makes you think about something completely different. I throw a couple of those in the future. That was a simple one. There'll be more complicated ones in the future. Okay, let's see what we can do and on whether we're not getting to the point where we finish this, because I think I have actually talked too much already and you guys getting a little tired, I see. I have to look at Anna's face. Yeah, she's still okay, all right. So what I also believe, and this is what I believe as a researcher and as somebody who is interested in creating innovation, is that I like to create tools and devices that help you shift from what we said before, from this sick care approach, people getting treated when they're sick, to a prevention approach. So making sure that you don't get sick, or to find out before you get sick how sick you get. So, I mean, if you think about a stroke, a heart stroke, if you would know that you need a stent, something that expands your arteries, that is a very minimal invasive process. You get a catheter moved through your femoral artery or carotid artery. They go into your coronary arteries, they place a stent, take it back out. You may have to stay a half a day or a day in the hospital, go home. What if you would not have done that? Would probably 3 or 4 or 5 or 6 months later, you would have gotten a heart attack, a stroke. And then you can either die, or your heart is dramatically reduced in functionality. That is expensive, and that is something that really harms you. But you could have actually prevented this very easily by having the right tools and right devices, maybe even a small device that measures the blood or listens to the blood flow. These are preventions you can do very easily, but none of us really does it because we don't have the tools available. And how many of you like to go to the doctor, by the way, including the medical students? Victoria, you love to go to the doctor, right? Are you still there, Vicky?
Yes.
And do you like to go to the doctor?
No.
Uh-huh. So the doctor doesn't like to go to the doctor. Nobody likes to go to the doctor because there's lots of sick people around. And who likes to be around sick people? I don't. So we need to do something about this. We need to prevent things from happening. And I think the doctor's role in the future will be more like a guide to keeping people healthy rather than treating you when you're sick. And I think that's a cool way of thinking of how doctors will actually be employed in the future. So this is already what I said, is this biodesign process. So normally what we start, and that's what we will do next time when we meet, we will focus on identifying problems and understanding the clinical process. And once we have that, then we can actually simulate or ideate around problems around this. So this is something that came out of a normal, I used to do this in the engineering department where we sent the students to the medical, to the clinicians, and then they came up with cool ideas. And that's a little bit of what we will do in this class as well. Okay, so we did this already. Okay, I think we'll go to this. What I have here, and this is just an example, is a description of a clinical problem. So anytime you see a clinical problem, particularly right now the clinicians, or if you guys as engineers talk to the clinicians, write down of what you see as a real clinical problem. If you have some time, you can also look to the INCA website. Maybe I drop this into the chat. Let's just see. Hold on. Let's just quickly do this. So where is my webpage? So if you go to the INCA website, there is it says here unmet clinical need evaluation. So if you go, for example, to all project, you'll see different clinical problems that we have defined. Interventional cardiac surgery, let's go in there. And you see some of the things that the students came up with. So a little bit of a description. What is the need statement? Who would benefit from it? What is the description of our proposal? And what would be an expected result on this one? Or something. Those are some of the ideas. Maybe that's also something that you can reference to with ideas that came out of the classes and maybe come out of this class as well. Every time you see something, write it down, make a problem statement. What have you actually discovered? What have you found out? And then you need to, at some point in time, check that with a clinician, say, by the way, I have actually seen you do this, but what about doing it a different way? Or what about using this device? It looks like really awesome, awkward the way you do it. I have an idea for you. And then you discuss that with him. This is the iteration process. And this is what we want to do when we actually create innovation in this space. So if you have some fun, go look at that, particularly the whole project. You can also enter here a new project if you want to. Okay, but this is what I have proposed with this sheet here, that we basically can use something like that to start and record these clinical needs if you find some. But again, you will only find them if you really go out with the clinicians. Okay, so this is something. I'm going to go over this because we'll do this next time. And I will just do 5 more slides and then we're done. Next time, I will give you an introduction into exponential technologies, particularly with respect to healthcare. And there's a bunch of technologies out there. You don't need to know all of these, but I've actually marked some that I believe are really relevant for healthcare space, and some of them that we work on at INCA as well. And I think that innovation in that medtech domain come only if you combine lots of these technologies, but always in mind having in mind what is the clinical problem that you're trying to solve. And you need to, that's what we said before, you need to have a little bit of a view in the future. So particularly the medical students and also the innovators from the engineering space, what will a future hospital look like? I mean, just think about it. Everybody is doing, who is in this space is trying to analyze what is really the future. You see here on the top of robotic surgery, this is the Da Vinci system. So Moritz and Anna are working a little bit on this device. We're creating some tools for that. We will have maybe some advanced biotechnology. Organ printing, a friend of mine in Australia, Professor Hutmacher, he's actually working on creating bone grafts, and he has them in animal trial already. So that's really cool that you'll be able to actually print organs in the future. Now think about what kind of effect that will have. Point of care devices. So what will the hospital look like? If you have an idea of what it will look like, you can go backwards and say, what do I need to develop right now to make that happen? I think Moritz and Anna and you have probably seen this before in Vitucha. Does anybody know this? This is Monty Python. Let me just run it for you. Do you all hear it? So that's about a 35-year-old movie.
And get the most expensive machines in case the administrator comes. Jolly good, that's better, that's much better. Yeah, like it?
So, what is missing?
The patient.
Still something missing, man. Patient. Yes. Where's the patient? Anyone think like patient? Ah, here she is. Bring it over here. Mind the machine. Sorry. Come along.
Did you hear this? He said, mind the machine. So be careful about the machine. Who cares about the patient? So I'm always trying to show this picture. It's not so much for the medical students here, but it's more for the engineers to make sure that everybody understands that we are actually ultimately we're doing things for the patient. We're not doing them for the doctor. We're not doing them for the healthcare system. We're doing them for the patient. And have some empathy. Everything we do should benefit a patient. And I'm not entirely sure if everything we do in healthcare at the moment is benefiting the patient. What we will see in the future, and that's why it's also important to look into money, the money space again. I don't want to stress this money issue too much. We'll have in certain countries, and I think, Christoph, you already mentioned that with Switzerland, we'll have a value-based approach. So reimbursement, hospitals or treatments will be reimbursed, paid for, based on their success. So you will not be able to do a chemotherapy and try it out. And if it doesn't work, you try another one and get paid twice. You will only get paid if it works, value-based. And you will actually have to judge on whether a certain procedure will have the promised effect. There will be money attached to that at just about any time. So money is something that you need to deal with in healthcare, and that will be very, very important in the future. And that's why it's also very important for us to think about how we prove that certain things that we do create an actual value for the patient. And we'll have something that's also, when you work in a hospital, is not happening. The healthcare system will move around the patient, hopefully. That's what we call patient-centered healthcare. And not the patient is being moved from left to right, from right to left. Go please to that specialist, come back to me, I'll send you to another specialist. Now you get to the hospital. The patient is basically always being pushed around. And we see this in other healthcare systems that are starting, to basically change their own setup. If the patient is not in the center, the experience of the patient will be low, and the experience of the physician will be low, and the cost will be high. So that will be certainly something that will be happening in the future. And believe it or not, in 1819, Sir William Osler said already it's amazing how different patients are from one to another. Surprise, surprise. It's almost 200 years old. So this is in reference to that we need to have something that is being done for the individual. So we call this personalized medicine. You've heard that all, personalized and precision medicine. So we're not doing a hip replacement based on 3 different sizes. We'll need to have a hip replacement based on my specific size. So individually made for me, personalized to me. And I think these are the core concepts of innovation that you probably should have in mind. It needs to be a value-based approach. You need to understand of what is the financial implication, what value does it actually create. The patient will need to stay in the center of the treatment, and it will need to be a personalized approach with precision medicine. It needs to be geared towards my specific problems and not a problem of 25-year-old females or 35-year-old males, and they're all kind of like treated the same way. No, it's me you're dealing with. And so these are some of the things that will cause dramatic changes in the healthcare system in the future, okay? And we'll have, believe it or not, we all know that, every one of us has one of those, right? And this device will also empower us. We'll be connected to a digital world. We'll be able to use ADA, which I mentioned already, which is a software tool which helps me evaluate my health status. There will be sensors built in where I can measure my ECG, I can measure my blood saturation, I can measure whatever, I can measure flow signals. All these things are available to me at home, which also means that I will be part of the healthcare system as a patient, not only as somebody who is sick, but as somebody who monitors his or her health status at home and is able to actually make decisions using technology. So I'm sure that that will happen, and that will be the developments that we need to consider in the future. So now the last ones. So I ask you, please, then we see each other Friday in a week, to just get a little bit prepared and do this EXO course. I know that Moritz did already, right? How long did it actually take you?
Overall 2 hours, I think.
So it's not a huge effort, but was it worth doing it? I mean, did you get something out of it?
I mean, I read the book Exponential Organizations already, so I was a bit biased probably, okay. But I think I got something out of it, yeah.
But if you would have not read the Exponential Organizations?
Definitely.
So please do this. It's just a very good, it's just a mind opener, okay? It may not have anything directly to do with what we do, but it's an opener to what will happen in the future. And again, this is a class that has a lot to do with the future. And what I thought was very interesting, because I was sneaky, I was actually looking at 3 people who already signed up. And so I checked you guys out. And it was, so Moritz already got his badge, so you see it on the left side, and he put down, what is his goal? And that's also something we will work on. It's called an MTP, a massive transformative purpose. What is your goal? What do you want to really do with your life? And so Moritz said, creating a new perception in surgery. I think it's kind of cool. So that's what he's working on right now anyway. Rutuja said she wants to improve the quality and availability of healthcare technology worldwide. That's democratization, affordable to all classes of society. It's a very, very cool goal to have that. And Anna said, I would work in medical technology and hope to make interventional procedures and devices more effective and safe for patients. That's a very dedicated goal. Maybe you can get a little broader, so you have a bigger goal, but it's a very good starting point. This already, makes you think a little bit about where you want to invest your time and your efforts. So I think that all by itself is a good exercise. So please do this. Check this OpenExo stuff out, get this foundation. That makes it a lot easier for me next week too, and we can go faster along. This is something I want you not to do right now, but I already want to throw it out to you, because I expect from you then after the next one, if you think about a technology or process solution proposal based on what you have learned, exponential technologies, I want you guys to think about, and maybe you can use what I've put down on the bottom left here. If you look at the risk behaviors, these risk behaviors drive 15 chronic conditions, which cost 80% of the total healthcare costs. So if we would address these, we would save 80% of the total healthcare cost. So why don't you just, I mean, it's a proposal. You don't have to do that. You don't have to use this, but why don't you think about a potential solution that you could think of using exponential technologies and approaches in 10, 15 years to solve these problems? So that's what I like you to do. Again, don't do it this time, do it next time, but I just wanted to prepare you already so you know what you can look for. But I also don't mind if you want to do something that you are working with. So Victoria, for example, if you told me that you are interested in prostate and brachytherapy and that stuff, if you see something there, just go for it as well. So it's just a proposal that you can do this with these big issues. But if you have more specialized, more dedicated ideas, then go for that as well. Okay, so that was it. Anybody have any major questions? Nobody? Christoph, you always have comments, right?
This time not, because I'm sitting already dressed up because I have to go to the Faculty of Informatics right now and do some work there.
Oh yeah? Are they still working?
Yeah, 24/7.
Oh yeah, here we go. All right. Yeah, we do quite a bit of projects together with so Alfredo's also teaching quite a bit of the digital engineering teams, right? How many do you have, Maurice, right now?